I'm gonna, well, first and foremost, just a quick acknowledgements. The Saskia, as Johan mentioned, I was part of the committee, and we had Saskia from Erlang Solutions, but unfortunately, she left ESL before the summit, so she did all the hard work, and yeah, I promised her that I would thank her for this. Yeah, and obviously Johan, Lovisa, and Peter. Um, yeah, he used to call us at weird hours, and yeah. But anyway, and the pivotal team, you guys know yourselves, Dan Cowan's team, and okay, and everyone else, but our customers as well, the Erlang Solutions customers who've come here from very far. I think there's Israel, I think that's the furthest. My guys, Ofia, and I don't know, why you here? And Alexi. Anyway, and the Erlang Solutions engineering team. Hey guys, can you just raise your hand so people see you? Lajos, where's Lajos? Shimon, please, can so have a chat with those guys after, maybe work together. Okay, I'm gonna talk on a bit of a challenging topic. Saskia approached me and said, hey, Ayanda, we're having a RabbitMQ Summit with Cloud MQP, and can you do a talk? And this was just after I'd done a meetup where I spoke with Carl, also spoke, and I was like, oh, cool, I can just use that talk for the meetup. And then after working with a whole various number of customers, Will is here as well from Bloomberg. I noticed that there's a need for guys to understand the internals a bit. So I was like, why not have one talk which is a bit diving deep on the internals for the conference. So yeah, we're going to try and explain the internal design. Attempt to explain this. It's not as easy. So I think with engineering, there's a common problem, or there's an ever-present need for efficient communication. So be it hardware, RF communication, you always have, or software, you always have two entities that just want to communicate efficiently. And I think RabbitMQ meets this need for applications very effectively. So you've just got two applications which just want to, simple case, two applications that want to communicate, and we plug in Rabbit in there. And yep, so yes, and just a quote before I start. There was a gentleman called Frederick Bernard. I'm sure you've heard this quote, a picture is worth 1,000 words. Right? And I was trying to justify my slides because then I came up with, a quote as well last night, that a software system diagram is worth 1,000 lines of code. So that's by me last night, So yeah, you see why. All right. So where do we start? Okay, we start with, so you download RabbitMQ, you install it on your server, right? And the directory structure is generally this. Oh, by the way, I'm on 3.6.1.5. Michael is talking about 4.0. We're still a bit behind. So we support all versions of Erlang Solutions. So yeah, you have your scripts directory, right? And in your scripts directory, you've got the Rabbit server script, which is basically what starts everything up, right? So you can check this out and just follow along as well. So what does the Rabbit script do? Basically, it'll execute the RabbitMQ script, which will basically initialize your environment variables, right? And it will set some defaults environment variables. So you can override these on your OS, which I'm sure most of you guys have done. And after that, it will execute the Erl command, right? And which will basically kick off the Erlang node, right? So that's the startup. And if you look at the script, if you scroll down, okay, on version 3.6.1.5, obviously, which is probably it's just the same for most versions anyway. You'll find the Erl command somewhere down the Rabbit server script, and then part of that command, you've got all the arguments that we passed to that for node startup, and one of the arguments, sorry, is the RabbitMQ start Rabbit environment variable, right? And if you navigate to where that is, you'll notice that that argument sets a boot module, right? And basically, the dash S argument will execute that module and that function. So basically, um, the, the function that will be executed will be Rabbit's boot, right, based on that argument. And basically, that's what starts Rabbit, right? So, and then what happens on boot? So the first thing which happens in boot is you get your application configs updated, right? And this is where your RabbitMQ.config file, right, where you define all your application configs. They get, I think in 3.7 now they get merged with the new config format, and you just get one config file, which is applied as the application config. And then you've got a whole bunch of other procedures that are carried out. You've got hype compile options, and yeah, and checking cluster consistency. I think Michael mentioned this, that I think in later versions, they're planning to have different versions running together. So you've got a 3.6 node running with a newer node, for example. So, and at the moment, if that cluster consistency check fails, your cluster, you won't be able to start your, node. And then broker start, obviously. So that is the next step. So what happens when you start the broker? It will set up your plugins, right? There's a whole bunch of procedures that are done within that set of plugins procedure. It will start all the applications, the dependencies, right? And you've got system D notifications, right, if you started it as a service. And then you get the log message on your logs. So if you noticed, RabbitMQ started, blah, 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 config file that, log directory that. So that is basically that part. And then within that start applications phase, right, there's an important step which Rabbit does as part of initialization, which is executing the boot steps, right? So RabbitMQ has got a concept of boot steps. I think for Erlang developers, if you've worked with start phases in OTP, it's a very similar concept, but this is a bit more, I find it a bit more flexible because you're not tied up to a single application file as you have with OTP start phases, right? So boot steps are basically going to run through a number of initialization phases, which are about this fancy, Yeah, so basically some of the boot steps, so there's quite a lot, right? So if you look at the Rabbit module, right, you've got a lot of boot steps that are executed. And basically, Rabbit will just run through all these, right, do some initialization, and maybe just a couple just to point out is you've got your alarming infrastructure that will be initialized, right? So all your memory alarms, will be part of that. You've got your file handle cache for efficient usage of your disk I/O. And you've got, there's quite a lot. And you can go into the Rabbit module and see all these, right? And then at the end, what you have is you've got more internal boot steps, which are not part of the initial boot steps, right? But these are like distributed across other modules in the code base. And then after that, you've got your plugin boot steps. So for example, I think Matteo gave us a great talk on building plugins, right? So if you do incorporate a boot step in your plugin, that's when it will get executed. And and then part of the internal boot steps that are executed, you've got your authentication mechanisms, right? You've got your queue mirror modes, HA all, HA nodes. You've got your policy validators that are initialized. And you've got a priority queue. This is interesting because priority queues are enabled by default in RabbitMQ, right? So that is always enabled. And we'll get to that at the end, but yeah. If you look at the backing queue module that is used by I think Matteo did point out a backing queue module again, used by the queue process. You'll notice that it defaults to the priority queue backing queue callback, right? And then you've got runtime parameters and a whole bunch of stuff that is initialized. Yep, and then, okay, so that's it. So your node is initialized. The boot steps have run. You've got your alarm processes running, memory monitor, node monitor. You've You've got your port and listeners running, right? And a whole bunch of other processes that are initialized. I'll touch on this later, right? And then you've got some recovery schemes which are executed as part of startup. So I think in the newer versions, part of those recovery schemes is to recover the vhosts, right? We noticed an interesting issue quite recently with the Will, who's sitting somewhere at the back, that there's some cases where that recovery phase was just taking way too long, up to 8 hours. But yeah, thankfully that was fixed. And yeah, so so basically this is when your node is initialized. And obviously there's more stuff. I could have added like a whole stack of OTP stuff, which is started under the hood, but we just focus on Rabbit. And part of initialization as well, you've got your Ninja tables that are started up, right? So you've got your Rabbit user tables, so all the users are stored in there. You've got your durable queues, which is basically transient and durable queue tables, your vhosts, Rabbit, and a whole lot more, right? The exchanges table as well. And then, okay, so that's initialization. So that's when your node is started, you haven't done anything, right? It's just, all plain, nothing running at the moment. Well, in terms of the operations that you're executing against it. And then after that, if we look at the Mqp operations, so just to try and explain how stuff works internally. So we'll look at the Mqp operations, which I think Gavin gave us a really great talk on Mqp. So he's literally done like half the job. Yeah, so our two applications which we mentioned, app 1 and app 2, they basically need to connect to the nodes and then start interacting, right? Your node is initialized, right? And we'll take the first step, connection establishment, right? So when your application, so just to explain this diagram, it's time and top. So this is your application. This is on your application side, and everything within this, that's the broker, right? So basically, when your application connects, right? So Mqp Connection Establishment, there's two phases that take place, which are abstracted to the user, right, to the developer. So all your client libraries will first open a socket, TCP socket, and then they will engage in Mqp handshaking, right? So internally in the server, you've got Ranch, which is handling all your TCP stuff, and then you've got a whole bunch of acceptors, which for each connection request that comes in, it'll handle that request, right? And then the moment the reader process, so the reader is actually the process that's going to handle your messages coming in from your socket. The moment that is started, right, it'll issue a connection start. So back to Gavin's talk again. It'll issue a connection start primitive back to the client, right? And the client will send back a connection start OK, and part of that connection start OK contains your login, your credentials, username and password of your application, right? And then there's connection tuning, setting, just agreeing on the heartbeat timeouts, and yeah, a whole bunch more of initialization that gets set up. And then after that, the broker is going to send a connection open OK, right? And that's your Mqp connection open. But there's two phases that took place, which, yeah, well, there's no need to be aware of that. I think all the client libraries which we have are, yeah, this is the same procedures that they'll do. And then after that, if you want to look at what actually happens in terms of the procedures, right, you have your Rabbit reader started, right, and then it will wait for messages coming in, right, in a loop. And obviously the first message will be the protocol initialization packet, which will contain the version, some bytes basically, which depicts the version which the client and the server need to agree on, right? So internally, what happens? Rabbit will check those 4 fields, right? And then it will match. It will match those fields and pick the Mqp version module, which it's going to use, right? So again, Gavin touched on this as well, the different versions, 0.8, and and for 1.0, that will start up the whole Mqp 1.0 infrastructure. And then after that, once we've set up the Mqp version has been agreed on, the connection pid is registered, server properties are set up. If you look at if you do a trace, you'll see a whole bunch of properties that are negotiated between the client and the server. And then that connection start primitive will be sent out from a Rabbit writer process. Right? So your connection is started. Okay, I didn't want to get into the Erlang side, but just a brief on the Erlang setup. So what you have is on the boot phases, right? You're going to have the Rabbit supervisor starting up. The TCP listener processes and supervisors being added to the Rabbit supervisor, right? And then Ranch. So all this is being taken care of by Ranch. If you know how Ranch works, basically what it does is got a whole bunch of acceptors, which Rabbit sets as 10 by default. And if this is configurable, there's a config which you can bump this up or reduce it based on your need. And then it will start up the reader setup, right? And then it will come back, and then your acceptors get back to the accept phase, right? And then each client connection that comes in, right, it will basically set up a reader, which is the handler for that client connection. And you can have as many of the Rabbit reader supervision trees started as client connections come in, right? So yeah, basically that's just a brief on the connection establishment. And then next, once you have a connection, you want to open create a channel, right? And channels basically internally in Rabbit are just processes which are going to handle the Mqp requests, right? So these are just handlers internally. We'll just look at that as well. So what happens when you send a channel open? So the channel open request will be handled by your Rabbit reader, like everything else, I mean. And then the channel top level supervisor will be started. That will start another supervisor for the specific channel, right? And then the channel process will be started, right? And the moment you get that channel process started, which are these guys basically, right? That will basically send back a channel open message to the already started channel, right? And so that's just for setting up, for updating the state of the channel, right? And just setting it to running state, right? And then after that, the channel open OK is sent to the Rabbit writer process. Yeah. So you can go to the code base and actually see all these implementations. And then after that, okay. So just to explain the procedures which are taken care of during channel establishment, you've got obviously your channel open request will propagate through your Rabbit reader, and that frame will get handled. So there's a check. So you're not permitted to use channel 0, right? Channel 0 is only for setting up the Rabbit reader process. So if it's not channel 0, then it will process the frame, right? And then it will do a channel lookup if the channel is already existing. Because all these channels, their PIDs are stored in the Rabbit reader process dictionary, right? Which is, just a RAM store. And it will check if it's already existing. If it is, it'll basically decode that channel open primitive, right? And then handle the method and cast it across to you. Okay, basically this is the part where I was like, there's a message which will be sent out to the channel to initialize the state. So this is what happens. It will cast that. So this can be across different nodes. It will forward that message, and that will set the channel to a running state. And that's when, your channel is started. If it didn't exist, it will create a new channel, right? And then there's a check if the maximum number of permitted channels are exceeded or not. And if they are, obviously your channel open operation will fail. If they're not, it will start up the channel and then come back to all these procedures. Right? And basically a channel consists of obviously the supervisor process, and then if it's a direct channel, it'll be, you just have your Rabbit channel process and a Rabbit limiter. And if it's a network channel, which probably most of you guys use, so if you're coming through Erlang or Elixir, you can open direct channels, connections, right? And if it's a network coming from a Java client, for example, or C#, everything else, you have a Rabbit channel process, a Rabbit limiter. So this is the handler for all your commands. The limiter is, so this is the guy who actually handles all your prefetch count mechanisms, right? So limiting the interaction between the queue process and the channel in sending out traffic, right? So that's the limit. That's the role of the limiter. And then you've got your Rabbit writer process, which is basically this guy who just issues out. Where is it? Oh, sorry. That guy who issues out commands back to your client. So that's channel creation. And then next, you want to create and declare an exchange, right? So what happens when you do that? Similar procedure. You exchange declare primitive, sent to the Rabbit reader, forwarded to the channel, and then there's a Rabbit exchange module, right? So this guy will do a lookup in Amnesia in the database and check if that exchange is already been created. If it's there, right, you get an OK exchange, and that exchange declare operation will be returned back to the client. If it's not found, it will create it, basically create the OK. Part of this procedure, the declare, is to look up which type of exchange that you have, right? So all these types that you know, direct, fan out, they translate to callback modules internally. And then after that, the exchange is inserted into Amnesia, into your database, and you've got exchange declare OK, return back to the client. Right? So pretty straightforward. And then some checks which are done for creating exchanges, it will check if the type is valid, right? So if it's within the direct topic headers scope, or if you write your own plugin, which like the consistent hash exchange, right? So that will be registered on startup, and the check will be basically carried out against that. If it doesn't exist, obviously it will fail. Your exchange declare operation will fail, and then it will check the permissions. Is the configure permission? Does the exchange have a configuration permission for the user, right? And then if it doesn't, obviously it will fail. And I think I mixed that up. Yeah, but basically, it will check for the permissions for the user to create an exchange, right? And if the user does have permissions, so yeah, I'm supposed to swap that around. It will look up the exchange. If it's there, it will return it. If it's not there, it will create it, insert an user, then return to the client. Okay, so now you've got your exchanges, you've got your channel, you've got exchanges. Now you want to declare a queue, right? So queue declaration, how is that handled? So when you create a queue, obviously you send your queue declare primitive, right? And then that will be handled, obviously there's the Rabbit reader there, which I've left out, handled by channel. And then there's an API for all, not most, queue operations in the Rabbit code base, the RabbitMQ module, right? So that will forward that will do a lookup against the database, right? And if, by the way, this, so basically to do a lookup, right? If the queue is already existing in the database, it will return queue declare OK. And then if, okay, that's when you've got the no wait flag set to true, right? But if you had set it to true, right, it will first confirm that the queue is actually created. So it will just get some initial stats from the queue process that has been started, right? So it will send out a stat message, which goes through a bunch of processes called delegates in Rabbit. So Rabbit has got a pool of processes called delegates, and basically what these processes do, they split commands. So any interaction with a remote queue, right, or a local queue, what delegates are going to do is you pick one delegate, and then it will split the commands based on whether they're for a local queue or a remote queue, right? And then if it's for a remote queue, it will actually ship across the command and execute it on the remote node, right? Which is more efficient than directly doing remote calls from this API. And then, yeah, so this will just return a couple of stats, and yeah, and then return your declare OK. So this is confirmed that the queue is actually started. So whenever you set that no wait flag to false, this is what will happen. And if the queue wasn't found in the database on the initial lookup, it will be declared, right? So your queue name, is it durable, auto delete, your arguments that you set from your client application, they'll be propagated to the queue supervisor, which will start the queue process, and then the queue process will initialize the backing queue, which has been configured for that queue process. So the backing queue is actually determines how your queue behaves, right? So you've got a process, and then behind the scenes you've got the backing queue, which varies how, or the types of queues that you have. So for example, you've got, like I said, you've got the priority queue. If you set priorities, oh wait, yeah, in the start I did say the priority queue is enabled by default, right? So basically the backing queue will be the priority queue, right? Which also interacts with the variable queue. So yeah, those are just callbacks at the back. And then that will send back your queue declare, okay, back to your client application. And just a few checks that what happens during queue declaration is, obviously that's the declaration call. And then if there are any policies that you had set, so your HA policies, those will be set on the queue, right? And if you've got any queue master location strategies set up, those will be set. Basically, you compute the node on which the queue is going to reside, right? And if it's a mirrored queue, you check the master queue node, right? So usually these are the same. I think there's an assertion in the code. And then that will then start up the queue supervisor, right? So this goes through another process called the pre-queue process. And then it will check, is the queue a master queue or a slave queue, right? So if it's a master queue, it will basically start the master queue with, and then initialize with the backing queue, and yeah, initialize your queue index, the message store, and I think, yeah. So for 3.7 now, the message store is per vhost, and yeah. So basically, you'd have a transient and a persistent message store, and then after that, your queue process will start, and then you send it another, okay, it's sent in init new, and that's the recovery strategy that's basically mentioned to the queue. And that will proceed on more initialization steps. So there's quite a lot that actually takes place. And then if it's a slave, yeah, the slave queue will be started from the mirror queue slave process, yeah. And then, all right, so you've got your queues now, right? And then now you want to create a binding between your exchange and your queues, right? So by the way, this illustration is just, this is logical. So bindings will basically exist in the database, as you're going to see. So it's not like you've got a direct link between your exchange and your queue. So you issue your queue bind command from your client, and mentioning your queue and your exchange, right? The source and destination. And then that will go to your channel, go to the Rabbit binding module, right? It will check, does does that binding exist in the Rabbit root table? So that's the table which holds all your bindings. If there's an element, it will return qbind OK. If there's nothing, it will write it to your database. And there's actually 3 tables there: the root, durable root, and semi-durable root. And then it will return qbind OK to the client. And just a couple of checks as well for the binding. So there's formatting of the source and the destination, which is your queue name and the exchange name. For example, stripping off carriage return characters in your queue names or exchange names. And then it will check write permissions for the destination, right? And is it a default exchange? If it's a default exchange, it'll fail. So you can't declare any default exchange. Because that's already done on startup by Rabbit. And then it will check read permissions. And then the Rabbit binding module will validate the binding, check in the database. If it's already there, if it's already there, it will return it. If it wasn't there, then it will create an entry in the database, and then issue it out via the Rabbit writer, right? So that's why the channel always has a Rabbit writer. So it will do some operations, and this is what will return to the client application. And then, once you've got your bindings, the next thing is we now want to subscribe our consumer to our queues, right? So that is when you issue out your basic consume command. So basically, similarly, your Rabbit channel will forward that basic consume command to your queue process via that API, right? And it will also mention the channel PID, its PID, the limiter, right? So I did mention there are 3 processes. So for handling your prefetch counts and all that. And then the moment it gets to your queue, the queue will basically interact with this RabbitMQ Consumers API, right? And within that API, which basically will create the consumer entry. So this is all within the queue process, and this is just an API. So it's not like consumers are standalone processes within the server, right? Everything is happening within that queue process. And then basically what it will do, it will request. Okay, it will initialize with the Rabbit limiter, right? And give it the PID to activate. And then what happens is, once that is activated, the channel PID, right, and the consumer entry, which is returned here, right? So this will be formatted into a record. That will be added into a queue. So you've got a small priority queue for each. Okay. So for each consumer that is created for a queue, is added into an internal queue in the queue process, right? So you have a queue of consumers which are added. And the reason why it's a priority queue is because that's why you can incorporate things like consumer priorities, right? So that's where consumer priorities come in. So if you want to prioritize your consumers, it'll be set within this priority queue in the queue process. And then the basic consumer key will be returned back to your client application, right? And then also there's some consumer created stats which are created. Yep, and then you've got your consumers now. So everything is set up. You've got your channel, exchanges, queues. You've got your consumers with their own channels, right? And now you're ready to publish messages from your client application to your consumer. And then what happens when you do basic publish? So if you push a message, right, it'll be formatted by the Rabbit basic API, right, into a delivery payload, yeah? And then, which is just a record. And then there's a root lookup. So remember, we want to deliver, so from this guy's perspective, he just wants to deliver messages to the queue. He's not aware of that guy on the other side. So all he wants to do is just send messages to those queues, right? So This root lookup is basically looking up which queues am I going to deliver messages to, right? So what happens is you get for each message, you get a list of queues, right? So if your exchange was a direct exchange, you just get a single queue there. Or yeah, if your exchange was a fan out, you get a list of queues, right? Or if you had multiple direct bindings which have got the same routing keys, you get multiple queues. Anyway, so that's based on the type of exchange that you have. And then those are forwarded to your delegates again, because these can be cross-node calls. Some queues can be local, some queues can be remote, right? And that delivery record is forwarded, to the queue process. And then there's a check. Okay, this is not implemented in the backend queue, but there's a check to see if the message is a duplicate. So at the moment, it just returns false by default. And then the first thing which Rabbit will do is the queue process will immediately attempt to deliver the message to the consumer, right? Well, it makes sense, because if you send a message, the first thing that you want to do is quickly check if this guy can receive it, right? But if you can't, that's when you queue it up, right? So that's the whole queuing theory. So there's an attempt to deliver the message, and that fails, right? And then the queue process will publish the message to the backend queue to insert it into the actual queue, message store, queue index, So basically, that's what takes place there. And yeah, I think I heard Gavin saying basic publish doesn't have a return. You just fire and forget. Yeah. So basically, that's what happens. And then a bit on the backend queue when it receives that publish command, right? So Rabbit backend queues are very interesting. So basically, when you get a publish command, there's a check, right? If the message is, if it's within what's the name of the config? If it can be stored in the Rabbit Q index. Exactly. Thanks, Johan. So basically, if the message payload is less than that Q index embed size, this is an optimization. It will be stored in the message queue, in the Rabbit Q index, right? And that will return okay. But if it's not, it will be stored in the message store, right? And in the message store, you've got the transient and the persistent. So depending on your delivery mode flag, right? If that was 2, right? When you publish for persistence, it will be stored in the persistence message store. And if it was 1, it will be stored in your transient. And then, yeah, that will be returned. And then the backing queue uses a message status record, which all the actions are acted on based on what's been updated on this message status record. And basically, after storing the message status record is also stored in the internal backing queue queues, right? So you've got a whole bunch of queues internally which the backing queue uses. So you've got Q1, Q2, Q3, and 4, and you've got message classifications called alphas, betas, gamma. So this is basically based on where the message is going to reside, right? So for example, a beta classification in a message exists on the disk, and its position is held in RAM, right? And so when your node goes through memory pressure, right, what happens is all messages that are in RAM are pushed to your deltas, right, to disk. So that's what paging, basically during paging, that's what will be happening. There's just shuffling of messages from certain queues to another queue. Okay, and And yeah, that's it. Your messages are now going through. Yeah, and that's where you've got messaging now. App 1 and App 2 are now communicating, right? And yeah, basically that's basically what, just an overview of what takes place internally when you interact in messages from one app to another. And then just a note on clustering, right? So when you decide to build your cluster, all it is you're just telling Rabbit that I've got another node called whatever, right? Node Rabbit2. And what it will do, it will just update the amnesia config with that node. And the amnesia will just handle everything else under the hood, right? Authenticating to the other nodes, using other distribution and synchronizing. So all your tables will be in sync across your cluster. And yeah, so all your internal routing will be now handled across the cluster. And I'm running out of time. Okay. And then just on HA-queues, I did mention the backing queue. The moment you set a policy to make a queue HA, the backing queue changes to the mirror queue master module, right? And the queue state will be updated dynamically, right? And then all your synchronization operations will be handled over Erlang distribution. So what actually happens is you've got your master queue process, which will be created. And if you set an HA policy, you get slave queues which are created on the other nodes, right? And then as part of creation, the master queue has got a coordinator process which it will use to interact with the GM group, basically. So just so basically what will happen is, because the master queue cannot directly interact with the GM, it will use that coordinator, and each slave has got a GM process which it'll handle events and react to events through and publish messages across the cluster. So basically this is all your clustering, replication, synchronization algorithm. And yeah, just to wrap up, so I don't think we can strictly define the architecture of Rabbit. There's a whole bunch of things that can cause it to change. Plugins are going to change how it appears, how it seems. Version releases are going to introduce new design changes. And just the way you use it, the design will always change. So it's an attempt to explain how it works, but it changes, right? And you can see all this that I've been discussing in these two repos, right? So Rabbit Server and Rabbit Kernel. And that's it. Questions?
Thank you very much. Let's do one quick question, and then we'll have a break. Actually, two questions.
Yeah.
One is, where can we get these great slides?
The slides?
Yeah.
Well, I think, Johan, I'm supposed to share those, right? Yeah, they'll be available.
And the second one is, if you are planning to expand your presentation to explain credit flow.
Yeah. I actually had a slide on
the mysterious credit flow.
I ended up cutting down stuff, so yeah. Yeah, sure.